Hello guys, welcome as we do the question before us. I read the question. The roots of the equation ax squared plus bx plus c equals to 0 are alpha minus 2 and alpha plus 2, where a, b, c and alpha are constants. Prove that. So guys, you are supposed to prove this equation. And so I start off. So the first thing guys is to establish our roots, our equation using these roots. And so for that, we can bring x, this root on this other side and this root on this other side, so that we have x now minus, we bring this one this side, this one now becomes alpha minus 2, this is now equal to 0. And also this one we can bring it this side. So you shall have x minus alpha plus 2 equals to 0. So guys, these are our factors. And so therefore, when we combine them, we can expand and we can find the quadratic equation. So it looks like this now. Plus 2. All these guys, this one now is our factors and they should bring us the result as 0. So to write up them in a better way, this is now going to be, so our equation now comes to that because this one changes to plus and this one now changes to minus. Now guys, we can expand that, and here is our expansion. So guys, the expansion is just normal, and so we now come and after expanding, we can now check and see what we can cancel. Guys, we can cancel 2 alpha and this 2 alpha because this is plus and this is minus. We can also cancel 2x and this minus 2x now plus 2x here. You cancel. And finally, we can write the remaining figures. So guys, this is what now remains. That is x squared, and this minus x alpha becomes 2 alpha x. Then we have alpha squared there and minus 4. Guys, from there we come to our equation. Our equation is written as x squared plus bx plus c equals to 0. And since we don't have a coefficient here, or the coefficient here is 1, guys, we have to divide throughout by a to make the coefficient 1 here. So that, guys, we can now equalize. All these now can be equated to this. So we shall have x squared plus b over ax plus c over a once you divide by a. Guys, now we can equate this equation and this equation. So we come to the coefficients. This is 1, this is 1. Here we have coefficient which is negative 2 alpha. That is the coefficient of x should be equal to plus b over a, or in other words, b over a. Coming to the coefficient of the constant, c all over a should be equal to alpha squared minus 4. And that's what, guys, we are going to equate. And so we continue. So guys, this is our results. We equated that to that and that to that. Guys, now we can make alpha the subject of formula here so that we can come and replace it right here. So this one is going to be alpha equals to b all over minus 2a. Guys, now we replace that in this equation. And so we shall have b squared all over this. Now you are squaring. This comes to 4a squared minus 4 is equals to c over a. Guys, we make b squared the subject of the formula. For us to do that, guys, we can first of all put all these under the same denominator, like this. We can put it under the same denominator. Here we have 4a squared, and then here we can put b squared. Now minus, for this, you are going to multiply 4 times 4a squared, which comes now to 16a squared. This is equals to c all over a. So guys, from there we can now put 4a squared on this side. So we are left with b squared minus 16a squared is equals to c all over a. Now we multiply by 4a squared. And guys, as you can see, the 1 over a will cancel. And now we are left with 4ac. Guys, this is b squared minus 16a squared. Making b squared the subject of the formula, we shall have b squared will now be equal to, we can start with the 16a squared because we are now bringing c on this side. That is 16a squared on this side. And this one will now be plus 4ac. Guys, we can now factor out 4a. So when we factor out 4a, we shall be left with 4a here plus c. So guys, this is our solution, and this is what we were proving, as you can see in our question here. So guys, you can see very well 4a, 4a, c, and this 4a. So guys, thank you for listening to me. Bye.